is a set of network basically, set of nodes with connections are there, with weights are there. So let's say this is the autoencoder. Autoencoder. So what is the nature of autoencoder is like this. This is the encoder network. And then we have, this is the some kind of data, let's say dimensionality reduction. Dimensionality reduction. Okay. It reduces the dimension of the data. Means let's say X feature vector belongs to R5. Okay. Then in this particular space, this X basically X prime will become X prime and will have dimension. It can have dimension R2. Okay. Then what this autoencoded device do? It reconstructs that lower dimensional signal using the decoder network. So if this is X is given as input, so you will get X prime. Okay. And the difference between X and X prime should be minimum. Okay. Should be minimum. See, now what is the first application? See, the first application of this autoencoder network is basically used for anomaly detection. Anomaly detection. Okay, let's say some set of feature vector is given to you. X1, X2, X3, X4, X5, X6, X7. And among these, there is a different type of feature vector is available. Let's say Y1. Okay. Then X8, X9, and X10. So what is the anomaly in this particular series? Is Y1. Okay. So how we can use this auto in X? These XY are basically n-dimensional. Okay. N-dimensional feature vectors. Now, given this set of feature vector, the question is how I can detect that there is an anomaly present in this series of vectors, which is basically Y1. How I will detect this? See, so the procedure is, this is the auto, let's say this is, okay. So this is the autoencoder net. Well, first of all, encoder network. Okay. So this is the reduced dimension of the input. Okay. Here you will give the input. Correct. So given this input, first of all, what you do, you take X1, give this as an input, reduce the dimension, and reconstruct the first of all, give X1, reconstruct the X1 tilde. Then give X2, reconstruct the X2 tilde. Give X3, reconstruct the X3 tilde. Okay? This reconstruction you have to perform. Up to how many points? Up to all 10 points. X10. Reconstruct the X10 tilde. But don't use, first of all, this is the supervised learning, first of all. Okay. Supervised. Algorithm is there. Okay. So you train your model based on this X feature vector. We trained our model based on this X set of feature vector. Now, what you do in the same network, before that, you notice the error between this one and this one. What is the error? Similarly, x2 to x2 tilde. What is the error? Same for x10 to x10 tilde. What is the error? Okay. And you note these errors. Note down. Okay. We take the inputs x1 and what is the reconstructed one. And we see what is the difference between the original input vector and the reconstructed input vector. And take the L2 now, whatever. Okay. Now next target is, so this is the training process. Got it? Now I give you something like this series. You have trained your model. Okay. Now I give you some new test data set, which is this. Okay. This is the text data set. So what you will do? This is your autoencoder, trained autoencoder network. Okay. So this is your network. What you will do? You give x11 first and reconstruct. You will find that if x and x tilde, the error between these two is similar, very similar to the error between these. Okay, then you will say x11 is not an anomaly. Not anomaly. Anomaly means something different among the neighbors, among the group. Correct now? Something different among the group. Unique thing or different thing about the regular pattern, hai na? Among the regular thing. Now what you will do? So you test it and you found that x11 is not an anomaly. Now next target is x12. So you have to check this. So what is the procedure? So you will find this, na? This root error, RMSE, whatever, L2 norm or R root mean square error, whatever you want to find, you find. So you take this. Okay. Now again, you apply x12 as input and reconstruct and check whether this distance is how much. If this is same as means it's similar to these ranges, these distances, it is also not an anomaly. Not an anomaly. Okay. Now next target is y1. So initially we means y1 is representing that, means for understanding purpose I wrote y1 is something different. But in a practical case, you don't know. Okay. You will assume this y1 as x13. Okay. Or x14. So you don't know. Your machine, you have to tell this is the anomaly. Okay. So what you have to do, you have to give y1 as an input and reconstruct the y1. Now, if you take this difference, this distance, the whatever distance this will come, the range of this distance in most of the cases will be different from these distances. Let's say these distances are something like this: 2, 4, 7, 5, 2, 7. Something these. Okay. So what you will find, you will tell that because this distance is somehow different from the normal differences, this may be possible anomaly. This particular feature vector is basically a anomaly one. Okay. So this will be anomaly. Okay. So in this case, what you did, you actually detect anomaly. So this is called anomaly detection algorithm. Anomaly detection algorithm. And autoencoder are very, very popularly used for this task. Autoencoder. Okay. So what are the applications? So applications are, one application is, say, let's say there are 50 persons are there. Their voices are there. So assume that out of these 50 persons, one person is not a authentic person of the organization. Okay. And you want to detect that person from their voice. Okay. Means you have trained your model on 50 pupil, let's say. Okay. And then one pupil, what it does, it resign the company. Okay. And you will find that after resignation of the one person, still 50 persons are there in the organization. They are coming. So you are worried that who is this one extra person? Okay. Because one person is resigned, the person should be 49. So how you will detect this anomaly? You can train your model on the sound signal, on the speech signal. Okay. Speech signal. Okay. After uh, training on the speech signal, you take then if this person come, this sorry, this is not one extra intruder, let's say intruder. If you take the sound of this intruder and give this to autoencoder, so obviously the original input speech and the reconstructed speech difference will be large, will be different. It should not be large, means it can be large, it can be small compared to other distances. Okay. So in this way, you detect the anomaly. Sound anomaly detection. Okay. This is called a sound anomaly detection. So there is one more very interesting application. Nowadays, you have seen that lots of cyber attacks are there, botnet attack. Correct? Botnet related to cyber crime, cyber attack basically. Okay. So let's say some series of samples. First of all, what you have to do, uh, you have to train, data set is given to you. You have to train your model first of all. Okay. You have to train your model on X1, X2, X3, X4. These, these data frames, these data vectors are basically, they are not botnet. They are not botnet. So you have to identify these botnet. Botnet are basically the spam thing. Okay, no, we don't want this as a botnet kind of thing. So you trained on the authentic data. So you trained it. Okay, I assume we trained this. Now, if any new series of vector feature vector or data samples are coming, let's say x1, x2, x3, and x4, and x4 is basically the botnet. Okay, x4 is basically the botnet, which is basically I am just writing y1, but x4 is basically y1. Okay, then x5, x6. So the same procedure you have to perform. That you have trained on these things. Now what you have to do? You have to uh, find the distance. So how you will find the distance? X1 and the reconstructed x1. Similarly, x2 reconstructed x2, x3 reconstructed x3, x4 reconstructed x4, x sorry. Uh, in x4, what you will find there is a abnormal distance, and this indicate anomaly, and this indicate this x4 or y1, x4 or y1 is basically what? This is the botnet data. Botnet data. So what you did here, you actually detect the detection of botnet. Botnet detects using auto input. Okay. So this is the thing. You can use deep auto encoder also. Now people uses this deep auto encoder also. Deep auto encoder. For doing the same task for better performance, and if you have the more data, you can. So just give me 1 minute, then I will. Okay. So this in this fashion, you can apply this autoencoder devices to any data set. It is not necessary that you have to apply this in botnet. You can apply this in any available. Uh, so, like in one thing is there, you can see how I can detect the video anomaly detection in videos. Anomaly detection Okay. Similarly, in medical data, medical, biomedical, specifically biomedical signals, anomaly detection in biomedical signals. Okay. So many things are there where which you can perform. Okay. So this is the thing. So, uh, so this is the procedure. Autoencoder is basically the design is such that it first of all reduces the dimensionality of the given data. है ना? If input is n dimensional, है ना? It reduces to m dimension where m is less than n, and then this is the lower dimension, and reconstruct the original dimension, reconstruct the original data of n dimension. So this is the overall procedure. Okay. So I suggest all of you to perform these two operations: anomaly detection in audio and anomaly detection in cyber attack. Okay. So this is done. So one more thing people also do, that is called anomaly detection and classification also. Anomaly detection and classification. Okay. First of all, you have to detect there is an anomaly, and let's say Wi-Fi is the anomaly. Okay. And let's say anomaly is divided into multiple categories. Okay. Multiple categories. One category is normal, means this is not anomaly. One category is uh, grade 1 anomaly. Then grade 2 anomaly. Then let's say severe anomaly. Okay, so these four classes are there. So again, you have to train on this four classes data set, and you will give this Wi-Fi as a test signal, and it will come to that which category where it belongs to. Okay, depending upon your training, whether this is a severe anomaly, grade 1 anomaly, grade 2 anomaly, or just a very normal type of anomaly. Okay. So